Okay, in this problem here, we are given a graph of a function. Cool looking function, huh? Let's see, this function is called x sine x, right? So our function here, we'll call it f of x, how's that, is equal to x sine x. That's what this function is. And we are asked in this problem here to find the integral of this function between 0 and pi over 2. Alright, we can change this up and do different things with it if you'd like, but in this particular one, let's say it was between 0 and pi over 2. So here, let me write this out on a separate sheet. Alright, let's say we're asked to find the integral between 0 and pi over 2 for this function of x sine x. And you should know by now that an integral is simply the area under its curve. Okay, the area under this curve, and its lower bound is 0 and its upper bound, sometimes they're called limits here, but not to be confused with derivatives and limits, that type of thing. But so we'll call them bounds here. Our lower bound is 0 and our upper bound is pi over 2. Okay, well, here's our function, and it's easy to see that here's 0 and here's our pi over 2. So since I already told you that in region 1, we call this region 1, that its area is 1, well, the integral here is simply just 1. And that's it. That's the total area. But that was too easy. Let's make it a little bit trickier here. How about if we did this? Let's find the integral between pi over 2 and 2 pi. Let's do something like that, okay? For our function x sine x dx, okay? Okay, so we're going to go between pi over 2 and 2 pi. And bringing our picture back here, do you see pi over 2 is right here and 2 pi is way down here. So we want all of this area. We want region 2, region 3, and region 4. Now, do you notice that region 2 is above the x-axis, right? Whereas regions 3 and 4 are below the x-axis, all right, below our x here. So if that's the case, then we're going to simply take region 2, whose area is pi minus 1. Okay, we'll start with that right here. This is region 2, whose area is pi minus 1. And from that, we're going to subtract the other two regions. Now, why are we subtracting the other two regions, region 3 and region 4? Again, because region 2 is above the x-axis, region 3 and region 4 are below the x-axis. Right? So anything below has a negative area, anything above has a positive area. Now that's when I say this has a positive area and these guys have negative areas, I'm talking about net area. Okay, net area. If it asked what is the total area, I would simply add these three up. So there's a difference between net and total area. Keep those two things straight. Okay, so I'm going to subtract region 3. And I'll just point out here real quick to you, region 3 was pi plus 1, right? Region 4 is 2 pi minus 1. So, but I'm going to wrap these in parentheses. And the reason I'm wrapping them in parentheses is because I'm going to use the distributive property on these negatives here. All right, I'm going to use the distributive property on these two negatives here, which will change the signs inside the parentheses. Okay, so final answer. Let's see. Let's work this out. Here I can take the parentheses away since it's positive already. Right? Nothing in front of that parentheses, so it's just a 1 that I'm distributing. Here, though, this is a negative 1 that I'm distributing to both of these terms over here. So it's going to be negative pi or minus pi minus 1. And again, I have a negative to distribute. Here a minus 1 to distribute. So that's a negative 2 pi plus 1, right? These two negatives become a positive 1. Okay, let's clean this up a little bit more because I think they just want our answer in terms of pi. But do you see that these two pi's right here cancel out? Look, I've got a positive pi, I've got a negative pi, they're gone. While we're at it, look, one of these negative 1s can cancel out with that positive 1 right there. So I'm left with negative 1, right, minus 2 pi. So there's my total answer. Hope that helps.